Living in a world of flashing screens and data overload makes technology feel like an untouchable black box, vibrating with more information than we can process. For many, the anxiety of AI is rooted in speed. The field of neural networks and algorithms appears to be moving faster than a normal person can learn. This page from the AI Mathematics series addresses that exact fear. It argues that beneath every AI system is something surprisingly simple: structured mathematics applied at scale. We navigate this complexity using first principles. This involves stripping a problem down to its smallest, most undeniable truths before we attempt to understand the whole. It is an approach defined by curiosity without surrender. You break the machine's complexity into simple pieces rather than kneeling before its capability. Returning to these fundamental truths is the only way to clear the fog. When we find the simplest pieces, the fear of the advanced system begins to vanish. Mathematics is often introduced as pressure and speed, but at its root, it is simply the study of relationships: more and less, before and after, pattern and change. As shown in this numeric example, machine intelligence begins by turning real-world information into numbers. Here, movie preferences for action or romance are converted into a simple list of coordinates. Once information is numerical, it can be mapped. These coordinates describe a vector, a specific point in a mathematical space. When many points occupy a grid, they follow a geometric rule. Points with similar characteristics gather closely to form a cluster. In this space, distance represents similarity. The closer two points sit, the more related the data is. What we perceive as recognition is actually the machine measuring geometric closeness. This geometric logic applies even to abstract things like human language. Words are also assigned coordinates. On this page, we see how vector differences capture relationships. By subtracting the vector for man and adding woman, the machine identifies the vector for queen. This allows for prediction. To choose the next word, a model calculates a score to find the nearest word vector in space. The process follows a mechanical pipeline. Raw data is transformed by math, leading to a decision, which is then improved by feedback. By stacking these simple pipelines, we create multiple layers of transformation. Each layer refines the coordinates, moving from basic patterns to the complex nuances of human speech. This interconnected system is a neural network. Its version of understanding is structural, geometry mapped over the patterns of language. Intelligence shifts from passive prediction to active movement when a system is granted tools to act on its environment. This creates the AI agent. An agent follows a persistent loop. It observes its environment, decides on a step, acts using an allowed tool, and improves its future behavior based on what happened. But machines remain limited by their training. They do not understand the weight of context. They only know their geometric clusters. If a query lands in a sparse region outside its known boundaries, the system must interpolate. It mathematically guesses a plausible but false answer, an error we call hallucination. Because machines interpolate blindly based on geometry, allowing an agent to act without human-defined boundaries is a significant risk. This identifies the absolute limit of automation. A machine can calculate the steps toward a goal, but a human must define the purpose and the consequences. This requires the human logic blueprint. By reviewing the output before the system acts, we ensure the logic remains under human care. Our tools do not replace our thinking, but unexamined delegation, handing over decisions without inspection, certainly will. This arrangement turns machine intelligence into a partnership. We measure tools by how well they serve human purpose, rather than by their raw speed. True intelligence is not found in the machine itself. It is found in the responsible, purposeful human who knows how to use it. This is just the first step on a larger staircase of learning. To explore the full, anxiety-free journey into modern technology, visit the complete Ravindra Nayak collection.